Okay, so we are going to try another example. And we'll do the second one on the sheet, which you can just follow along with me. We're going to relabel our column time, t, and then it's in seconds, right? And done. And then again, I'm just double clicking on the y, and I'm renaming it distance, and I'm calling it b, and I'm putting it in meters. So when I do that, I get a graph of distance versus time. Just so you know, you can, if you decide you wanted to do it differently, you could actually click once on the title of the column, of the axis, and you can pick whichever variable you want. So in this case, I could go time versus distance. Instead, I'm going to go distance versus time. Again, we'll talk about the reasons for the graphs, why you do them the way you do them. But let's quickly enter our data. 0.2. Okay, so that's that. And then for the distance, we'll enter and 75. Okay, so taking a look at this data, a couple of things. There's a command, you can find it on the topics page, but Command J will get you a nicely spread out data set. We're going to look at this and say, okay, what does this look like to us? Going back to, if I can find it, this. What does it look like? Which shape is it? It's definitely not the first two. Let's see. No, it's not the it's not this one. This looks promising. So in this case, we've got y versus x squared. So remember, what we're going to do is we're going to go to data, new calculated column, and we're going to square time. So literally our variable name will be time squared. The variable is t squared, and the units are seconds squared. So once we do that, we have to calculate it. So in this case, I'll click in there, and then I'll select my variable. In this case, it's time. And I don't think there's a squared function, so you're just going to say it's shift 6 to the power of 2. So that's time squared. And I say done. And now I can go down here and click once on time, and you can see now, you see that we've got this new calculated column. We can choose time squared as the y-axis, as the x-axis instead of time. So I'll put that there, and hopefully what you'll notice is another straight line. So I will graph it. I'm going to make this bigger by clicking appearance, and I'll just put it. That way you can see it. So you can see that I've got a really nice straight line, and here's my fit. And we will take it over and annotate this graph to actually figure out what the equation is going to be. All right, so now here we are, and what we're going to do is use the data here. We've got the slope, we've got the intercept, and we've got the equation here. All right, so what we're going to see is that we're going to have an equation in the form y. Let's see, we're going to have it in the form y equals mx plus b. And again, what is y in this example? Y is distance. And what is x? Well, we manipulated our data, right? And we squared time. So x is not this time, it's time squared. Time squared. So when we go to write our equation, what we're going to say is that it is d, so y is d, equals, now what's our slope? In this example, it's 3. 3, and what's x? T squared. T squared. Now this is something I want you to pay attention to, the b. We have this rule. If the value of b is less than 5% of the biggest y number, we're going to ignore it. This is times 10 to the negative. This is 7.86 times 10 to the negative 15 is an incredibly small number. We're going to treat that as an artifact or an experimental error, and we're going to ignore it. So what we end up with is this. Our equation of our line is d equals 3t squared. So you see we went from a graph that was shaped like a parabola, and we turned it into this straight line, and we were able to drive an equation from that. Now, what I want to also show you is how you are filling this in. What you're doing for the first one, what we found was, I can't annotate this. All right, we'll leave it at that.